Welcome. I'm happy about the opportunity to present our work on the 3D reconstruction of the right ventricle from 2D segmentations of sparse short and long axis cardiac cine MRI views to you. Accurate segmentation is a crucial prerequisite for quantification of the right ventricle and in turn diagnosis and therapy planning, but there are some challenges associated with this. Segmentations based on the short axis stack often do not cover the apical region well, which you can appreciate in the images to the right. Here we superimpose the region covered by the short axis segmentations onto the corresponding long axis image. Also, both the slices from the short axis stack and the different views are affected by breathing motion. This misalignment between regions and landmarks from different images. In addition, the right ventricular valve planes are challenging to identify. The tricuspid and the pulmonary valve are tilted with respect to the short axis image plane. Contrast between the upper regions of the right ventricle and the left ventricular outflow tract can be poor. The approach to meet these challenges is to not create the quantification from the short axis segmentation alone, but to integrate information from the short axis images and the additional long axis images provided by the challenge in a single 3D model to improve the volumetry. For the 2D segmentation, we employed a 2D unit which we pre-trained on in-house segmentations. This dataset includes 99 subjects, of which we used all cardiac phases. It also includes images from the well-known AC/DC challenge as well as images from children cases. We then refined this training by adding the M&M-2 challenge data with 160 subjects, of which we had end-diastolic and end-systolic segmentations. In the next step, we created a 3D model from these two complementary views. First, we identify the valve plane and the apex from the long axis segmentation, illustrated on the top left. From the contours of the short axis segmentations and the apex position, we triangulate an initial model. To refine the model in the complex valve region, we first restrict our mesh by the valve plane that we have identified. We use a position-based dynamic simulation constrained by intensity information from the short axis view and geometric information from the long axis view to deform the mesh towards the valve plane. The result of this you can see in the upper right illustration, with the orange part showing the deformed part that was added to the mesh. To evaluate the 2D segmentations, we calculated the Dice and Hausdorff metrics. The Dice values look quite good for both long axis and short axis, indicating reasonable agreement. For the Hausdorff distance, we see some larger differences, in particular for the long axis images. When we inspected the images, we noticed that these poorer performances happened in particular in the basal regions of the short axis stacks, as shown here on the right, and with more unusual shapes of the right ventricle in long axis views. To assess the 3D models that we reconstructed from the segmentations, we did not have any ground truth data. So we compared the volumes from the model and the volumes from a purely short axis segmentation. This relative volume difference showed us that the model consistently underestimates the volume when compared to the short axis segmentation. An illustration on the top right, with blue being our model and yellow being the short axis segmentation, also showing the effect introduced by the short axis slice sampling. As the slice sampling apparently affects the volume, we included another whole heart reference data set with higher resolution, which we segmented and resampled to a comparable short axis view. You can see this reference segmentation in yellow in the bottom right, and our model in blue again. Here we observed that the short axis segmentation overestimated the volume from the true ground truth, and our model again underestimated the volume when compared to the reference. So to conclude, we've seen that segmentation from the short axis view might estimate the right ventricle volume incorrectly, in particular because of the effect of the slice thickness. A 3D reconstruction of the right ventricle potentially improves the accuracy of the volumetry. We have also seen that the multi-slice and multi-view data is subject to breathing motion, and that the model generation would benefit from data with improved spatial alignment, either due to improved acquisition or, for example, some registration technique. Notice that the short axis view is not oriented with respect to the tricuspid valve, but with respect to the left ventricle valve plane. And the valve plane identification might also improve with a different orientation, more geared towards the right ventricle. Thank you for your attention.